So anemia of chronic disease is the second most common cause of anemia in hospitalized patients. And it's a type of microcytic anemia. Microcytic anemia. So that tells us that anemia of chronic disease is somehow due to a problem in producing hemoglobin, because we know that all microcytic anemias result from a problem in producing hemoglobin. So the second thing that's really important about this disease is that it's always related to some inflammatory condition. So that's to say that there must be some source of inflammation in the body for this disease to result. Now, anemia of chronic disease has absolutely everything to do with the molecule hepcidin, which is a polypeptide. It's just a fancy term for a chain of amino acids that's produced by the liver that serves as the body's major iron regulator. And by regulator, I mean that when the serum iron levels are low, when the body's iron levels are running low, there's a low production of hepcidin. But when the body's iron stores are running high, or when there's an excessive amount of iron in the body, the liver increases its hepcidin production. And it does this because the hepcidin then turns around and it decreases serum iron. Decreases serum iron. And it does this, it decreases serum iron in a couple of different ways. And to understand how it decreases it, I guess we'd have to go back for a couple of seconds to understand iron physiology. So we talked about how iron is absorbed in the duodenum, but something we didn't mention is that at the base of these cells in the duodenum is this channel called ferroportin. And ferroportin is what allows the iron to go across these cells in the duodenum and be absorbed into the bloodstream. Now, hepcidin comes in and it blocks the ferroportin channels. And by doing so, it inhibits the absorption of iron from the gut. So that's the first way in which hepcidin acts to decrease serum iron levels. Now, I'm going to scroll down just a little. Okay, so secondly, let's take a look at the liver. And here's a blood vessel that has blood in it. And we know that blood has lots of red blood cells in it. And every 120 days or so, each one of these red blood cells is taken out of commission. It's retired. And it's degraded by cells in the liver called macrophages. So these red blood cells are broken down by the macrophages. And inside the red blood cells, we know we have lots of hemoglobin. And the hemoglobin has iron in its center. And the iron that is released from the degradation of the red blood cells isn't just thrown away. Instead, it's saved and it's recycled to be used later on to make new red blood cells. So what hepcidin does in this scenario is it comes in and it inhibits the degradation. It prevents the degradation of these red blood cells. And it does so to prevent this iron from being saved and being recycled later on. So this is the second way in which hepcidin acts to decrease serum iron. So moving to the side just a little. So just to quickly summarize, what hepcidin does is it decreases serum iron by decreasing the absorption of iron from the gut and decreasing recycling by inhibiting the degradation of red blood cells. And in normal people, hepcidin is released in response to an increase in serum iron. Right? So it's essentially the body's compensatory mechanism to deal with too much iron. Now, in the case of anemia of chronic disease, hepcidin is released in response to any inflammatory condition. So any condition in which there's inflammation. So firstly, what do I mean by inflammatory condition? Well, I mean things such as infection, because we know our body mounts an inflammatory response to protect us from infections. Now, I also mean things like cancer, because malignancy is a pretty inflammatory condition, and also autoimmune diseases. And usually what comes to mind with autoimmune diseases is things like rheumatoid arthritis or lupus, but really any autoimmune condition can do the same thing. So these are just three of the most common causes of inflammation, but really there's several other disorders that could lead to the same response. Now, when there's any source of inflammation in the body releases cytokines, or small signaling molecules. And these cytokines cause an increase in hepcidin production. The hepcidin then decreases the absorption and recycling of iron to lead to a decrease in serum iron. That much we've already established. Now, this decrease in serum iron then leads to a decrease in hemoglobin production. And that decrease in hemoglobin production is what leads to the anemia. And that's how an inflammatory condition or a chronic disease leads to anemia. Now, I guess something that we haven't really addressed very well is why would you want there to be a decrease in serum iron in response to an inflammatory condition? Why does this pathway even occur? And the response to that is really important. So in conditions such as, for example, such as infection, bacteria thrive off of iron. They use it as an essential nutrient to grow. So really what the body does is quite smart. It essentially plays keep away with the iron. So it releases hepcidin to keep away the iron so that the bacteria can't use it to grow. And really the same thing occurs in cancer and in autoimmune condition in which these cells use iron as an essential nutrient. So that is essentially the background and the pathophysiology of anemia of chronic disease.